here with Matthew Borgatti with Super Releaser. How are you today?
I'm very good.
Yeah, I think the connection just froze for a sec, but should be fine.
Oh man. Better now?
Yep.
Cool.
Okay. So, what kind of work does Super Releaser do?
So Super Releaser is a soft robotics company. So I and Carrie Love, a spacesuit designer, run this company that essentially does the opposite of most robotics that human beings have ever made. The general thesis is that almost every biological mechanism is soft materials moving soft materials. So even though you might have bones in your arm, they're cased in soft material and they're being pulled by soft muscles. And there's a transition between soft muscle and then slightly firmer tendon, and then you have little pads around all of your bones to make that interface. And so we think about that in our engineering to design functional machines.
Awesome. And how does that compare to what most people are used to thinking of as a robot?
Yeah, so sometimes it's sort of difficult to explain because, you know, mechanical engineering relies on a lot of finite element analysis and things that assume that the objects have no bend unless they're failing. And for us, bend is everything. And so we specialize in textiles and cast elastomers. We do a lot of simulation in iterating. Essentially, we're running analog simulations where we'll actually make a rapid prototype mold, make a demonstration object, and then look at its actual properties, which is very different than your usual robotics design where you might, you know, spend 9 months making CAD on a precision robotic arm and then only manufacture it after the CAD is perfect. For us, it's about prototyping and playing with the properties because in many ways they're very difficult to simulate.
Awesome. So, could you tell us about this subcontract you carried out for NASA and Final Frontier Design?
Yes. So Final Frontier Design is a spacesuit design and manufacturing firm in New York. They're actually housed in the Navy Yard, which used to be a shipyard in Brooklyn. And they specialize in a new style of spacesuit. So one of the limitations on spacesuits right now is how dexterous they can be. So NASA has very discrete measurements of exactly what you can do with your hands. And in space, on a spacewalk, you're required to do a lot of really delicate stuff as if you were wearing like big winter mittens, and it's very hard. And the new style of spacesuit that Final Frontier has been developing is called a mechanical counterpressure suit. That is essentially a second skin that replaces the airbag that's keeping pressure in on your skin from the vacuum of space with this second layer of skin that actually changes its size and shape as you move your hand. And so the pressure is even, but it's an incredibly thin layer. And so what we did on that was we developed these soft robotic components that are part of that system that make the transition from the old spacesuit to the new kind of glove with this transitional layer called a wristap. It's essentially like this organic muscle that squeezes in on your arm so that blood can still pass through, but air can't escape.
I see. So, what do you see as the future of robotics in space?
Yeah, a lot of the vision I have for it is collaborative robotics. So the genre of robotics that we're chasing offers a lot of cool interfaces for people, whether they're good haptic interfaces where the impedance of the robot's motions is matched to the softness of your skin. So like having something give you really, really fine signaling on your skin to tell you information, or whether that's having a robot that's on your body as an exoskeleton. I see this genre of softness being part of how humans and digital information and digitally controlled motion can interact. You know, one thing that's cool about the mechanical counterpressure suit is it's essentially a robot that you wear. It changes its shape with you.
Okay. So, what do you see as the biggest misconceptions about the aerospace industry and robotics like yours?
Yeah, so In my experience in the aerospace industry, I don't think many people realize how multifaceted it is. It's lots of little companies in addition to like Boeing and Grumman and NASA's own fabrication facilities. There are actually lots of small contractors like me in the space of space. So not only SBIRs, the research grants that NASA issues, and various educational grants and collaborations with universities, but NASA actually has a lot of contracts that go to specialty manufacturers like me to develop parts that they don't have in-house capabilities for, or that they want backups for. NASA actually relies a lot on trying to develop manufacturing expertise where it's not just locked into one contractor and one contractor only, because they see that as a strategic risk if they need to like double the volume of production, or if they get caught in a bind where that one manufacturer is like they raise their prices by 5 times. And misconceptions for my kind of robotics, you know, I wish I were in a place where there was well known enough that there would be misconceptions. Right now, the big challenge is actually this genre of robotics is new enough and novel enough. It's difficult to point to successful examples and say, if you thought of this system in a soft way, here are the kind of victories you could achieve. Because biology obviously does it well. There are lots of cool experimental grippers from companies like Soft Robotics Incorporated, and NASA's JPL and Aaron Parness have developed some really, really cool soft grippers that act sort of like insect feet that just grip by having a lot of tiny little surface details that grab into like Martian rocks. But outside of like Big Hero 6 and Baymax, it's hard to point at a soft robot and be like, we're making one of those.
Awesome. So if you had the opportunity to join a space colony, what elements would you look for before you sign on the dotted line?
Yeah, well, I think 2 things. One, you know, working with Carrie, spacesuit designer, I constantly learn new things about spacesuits, especially how they fit and how they're designed and how the textiles interact. And so what's sort of intimidating is listening to her sort of talk about the structuring of a spacesuit and realizing how complex the problem is, and making that wear without needing repairs or without needing replacements, and fit a variety of people. Say if you had a substantially large colony where you wanted spacesuits to be, or you know, Martian HAB suits, to be interoperable, where you could replace gloves if your gloves busted. They wouldn't be custom made for you. You could switch it out with somebody else's gloves. That seems like a gigantic challenge given how varied human bodies are. And I participated in a program in college that was called Incremental Architecture for Lunar Habitation. And NASA essentially had this problem of, if we wanted to make a lunar colony, what mission critical stuff could we leave behind or get a double purpose out of to leave something like a lunar lander on the moon that had interoperable capabilities to be joined together, say, with other units and form an ISS-like module, a station on the moon. And what was sort of a fantastically hard problem to design around is, how do you make space for redundancy when payload is incredibly, like, minimizing the payload, maximizing the mission, the things that you can do on the mission, the number of scientific instruments you're bringing up, the redundant components. How do you make space for things that have multiple purposes and can be reused, that are also being made by dozens of different manufacturers with their own specs for screws and their own materials they specialize in? And the challenge I'd like to see conquered, you know, for me to be comfortable on Mars, would be some systems that are well integrated. What's very difficult with making novel systems, you know, you remember laptops 20 years ago, where they were very big, partially because if you opened them up, there was a lot of space inside. One of the difficulties in creating good systems integration is it's so hard to know everything about a system and how it affects everything else until you've flown it a bunch of times. And so for a Martian base, you know, what I'd like to see in the kind of engineering, the difficult problem in my mind, you know, setting aside radiation and, you know, if there's an emergency, how do you turn around? setting aside like some of the more sort of fundamental single point failures, it's how do you create Mars-like environments and get that equipment tested and integrated in such a way that you know it so well, you've refined it so that you know, like you remember Apollo 13, the movie, the two different CO2 scrubbers were not interoperable. They didn't fit in each other's housing despite the fact that they were less than 10 feet apart. And those kinds of problems are the kinds that you only realize after you've run a thing for a while. It's like Chernobyl having a failed backup sensor. And when checking the initial sensor, they looked to the backup sensor read fine, and they were like, well, it must have been the initial sensor that had the problem. It turns out that wasn't true, and that was actually part of the procedures for like scrubbing out crystallized minerals from pipes. Like, it was a thing where you wouldn't realize you had a problem until you put everything together.
Awesome. Well, that's all the questions I've got. Anything you'd like to add?
Sure. The thing I'd like to add is just sort of how exciting the area of space is for solving these kinds of problems. Like, one thing that's been really exciting about working in space with a novel branch of robotics is that it offers us this opportunity to experiment and refine our ideas inside of this territory where people are excited, but they also demand results. It's really cool having the opportunity to interface with NASA because they test and they evaluate and they're very, very rigorous. So unlike maybe creating a consumer product where you wait years to see what your consumers actually feel about it, the rigorous testing, helps us elevate our thinking, because if there's a problem, NASA's gonna find it.
Awesome. Thanks for joining us today.
Thank you so much. Thanks for having me on.